Hello. Today I won't begin with some boring magnetometer graphs. Instead, I will move straight to the lowest levels of celestial interactions. I mean the atmosphere and weather patterns. Let's start with the dislocation of northern polar vortex. On the last images we can see that the air circulation over northern hemisphere is clearly tilted towards North Pacific. Over the southern polar cap, the wobbles can be seen as well. However, it's much harder to point out the direction of polar vortex tilt. Problem is that changing air currents are only a result of a process which is much more scary. Although I spoke many times about the planetary wobble and tilt of rotational axis, I didn't know that the situation is so bad as it seems to be. Just watch the animation. I won't make any comments about those pictures. Instead, I will show you images taken by another satellite. They don't differ too much from each other. Now, check out the visible spectrum of light. The wobble fits perfectly to the zenith angle. Sadly, data from other satellites is being modified to hide the fact that our planet is wobbling. To demonstrate how bad is the current situation, I will compare two images taken on May 2nd and 3rd by GOES East at the same hour, 20:45 UTC. Look closely at the reflection of sun on the Earth's surface. I don't think that the difference between zenith angles should change that much in just 24 hours. Besides, despite all the efforts to hide the truth, we can still see the tilting Earth on single images, which somehow pass through the censorship. And while we're still looking at the global imagery, I need to make a small warning for people who live in South America. Something bad is happening with the geomagnetic field lines over this area. Better be prepared for severe weather in the near future. Sadly, it seems that the reconnection between open South Polar Cap field line and equatorial belt took place before I've managed to publish this movie. Now we can only wait for the effects. Over the South Pacific, things started to go wrong already. Such configuration of field lines is for me something completely new. But the situation over the northern hemisphere isn't better. Looking at the polar vortex, we can easily notice that over the Pacific, air currents are turning back against the counterclockwise rotation. It's just my small guess, but I think that all those opposing currents are the main cause of those giant waves, which are causing a lot of mess over bigger part of western coast of Latin America. Time to talk for a while about recent space weather activity. Most important event in last days was the CME impact at midnight on the 6th of May. However, the BZ component of IMF oscillated mostly around zero during the impact and turned south once in the afternoon, reaching minus 10 nanoteslas. This caused a brief geomagnetic storm and Kp index reached 5 points. It seems that there are some problems with the new SWMF plus RCM magnetosphere monitors and a lot of frames is missing. That's why I will use the older version to show you the impact and compression which it caused. Now, check out how the energetic particles from the CME plasma enter the current ring. This monitor shows the protons at 13 kV. But now, look what started to happen with those particles one day later, on 7th of May. They just started to disappear. Loss of particles can be seen at all energy bands of protons. However, electrons seem to be unaffected at all. Of course, my model explained this phenomenon as the influence of low energy field, which I think is the main source of all changes and disturbances. Here we can see the negative flux tube, which is sucking out entire positive energy from our planet. Funny, but it seems that the proton's outflow is causing much more interesting disturbances than the CME impact. The backside pressure is very strong. Of course, all those disturbances caused a lot of mess in the ionosphere. I've managed to capture a couple interesting readings from Millstone Hill convection model. Here we can see that ionosphere became a multipole with 3 separate positive poles and single negative one, at least over northern hemisphere. Notice as well that positive potential is much stronger than negative one, -2 to 18 kV, even if it looks to be much more disturbed. From the ionosphere I will move smoothly to another subject about which some of you asked me recently: local geology and magnetic attraction. In my previous movie, I've said that field lines like to connect themselves to the areas where the crust is weak. Let's see if I was right. On RSOE map, we can track easily all the most important fault lines and borders between tectonic plates. One of the deepest ones on Earth's surface is placed northeast from Australia, on the line called Ring of Fire. I will concentrate for a while on Solomon Islands region, as some serious seismic activity is currently taking place there. Just after 7 UTC, on 7th of May, a 7.2 magnitude earthquake was recorded on Solomon Sea. On the HMF2 monitor, we can see that around the same time, some interesting ionosphere disturbances were recorded over this area. And now the best part. Let's see if those magnetic reconnections affected somehow the cloud formation over the epicenter. Take a closer look at those clouds. Before the quake, some pretty active clouds were hovering above the Solomon Islands, but suddenly, at the time of quake, they've lost almost entire energy. But look how it affected the storm cell north from Ecuador. This is where this energy was transferred. Sadly, most of areas where the crust is weak is not marked on RSOE map in any way, like the famous New Madrid fault line. However, you don't need to be a geologist to guess what such huge crack in the Earth's surface can mean. Maybe it's just one of those famous coincidences that atmospheric field lines stick to this area pretty often, causing a lot of severe storms and tornadoes, but I don't believe in such thing as coincidence. Just look how much energy those field lines are capable to unleash during magnetic reconnections. Maybe it will sound weird, but besides all the extreme weather and natural disasters, reconnection can cause as well some pretty atmospheric phenomenons. Just look at this strange wavy cloud formation in Southeast Asia. But let's go back to the space above us, as during last couple hours Earth is experiencing another coronal hole stream impact. Initial event elevated the velocity of solar wind to 400 km per second. Second wave was much faster and reached almost 600 km per second. Like most of fast solar wind streams, impact was preceded by a very dense frontal wave, filled with giant nails and needles. One of those spikes exceeded 140 particles per cubic centimeter. Increased density caused a strong compression of magnetosphere, what was recorded by GOES satellites. Although the spikes usually shouldn't cause any geomagnetic disturbances, this particular density wave caused quite a lot of mess on some magnetometer readings. In Kiruna, geomagnetic field fluctuations exceeded 600 nanoteslas and the local K index was raised to 7 twice in the morning of May 11. BZ component was mostly negative in last days and magnetic orientation of IMF is still freaking out till this moment. However, according to SWPC, actual geomagnetic storm took place one day later, on May 13. KP index grew to 6 points just after midnight and remained at level 4 for the rest of the day. And indeed, during this time some rather strong disturbances were recorded by ground magnetometers all over the globe. Most possible cause can be found on the ACE magnetic field readings, where you can see that just before the geomagnetic storm, instabilities of BZ component became much stronger and reached around 15 nanoteslas, enough to affect the whole planet. Another thing which is worth to notice on this graph is that sudden shift of IMF orientation, which was recorded soon after the increased geomagnetic activities. I think that it was this event what caused the disruption of ongoing proton event, which was triggered by one of recent solar flares. Now check out the HMF2 monitor, on which we can see some pretty strong disturbances of ionosphere. You will think probably that all those sudden anomalies were caused by the recent geomagnetic instabilities, as it is the most reasonable answer. But logic doesn't seem to work in this case. Problem is that despite the lack of any significant geomagnetic instabilities during the last day, ionospheric disturbances doesn't seem to calm down. Actually, it looks that HMF2 anomalies are even growing in strength. The question is if there is any possible correlation between the strength of ionospheric anomalies and areas which are seismically unstable.
Let's begin with the biggest and most significant fault line, the Ring of Fire, especially the part under Western Pacific. First, let's check if there is actually any kind of increased ionospheric activity over this part of the globe. I think that there shouldn't be any doubts. In this region, ionosphere is disturbed pretty often by the negative and positive magnetic low energy field influences. Sometimes, like on this image, we can see both polarities placed right next to each other. Such configuration means that a connection between Earth and low energy field was established over this area, and the disturbances became much stronger. And now, the best part. Let's see if the ionospheric anomalies affect the environment in any physical way. This map shows the sea surface height anomaly. Colors represent the differences of sea surface levels, from minus 60 to 60 centimeters. Notice that east from Japan, the lowest and the highest values are placed right next to each other. I wonder if I'm the only one who guessed that it might have something to do with opposite magnetic polarities. But there is still much more to talk about regarding climate disturbances caused by the rogue magnetic influence of low energy field. This map, for example, shows the anomalies of sea temperature. As you can probably guess, red color means that in this area water is warmer than the average levels. Blue color shows the regions where the temperature is lower than it should be. The scale is from minus 8 to 8 degrees Celsius. And just like before, the most extreme values seem to stick together in the area of enhanced magnetic influence. Only why it doesn't surprise me too much. If you wonder if besides the long-term climate changes there are any visual proofs of the low energy field influence, just look at this short animation. Currently, there are two separate flux tubes which are hovering exactly over this part of the globe. It's hard to say which one I should point out for you, so I simply marked both of them. Before I will move further, I need to show you one more side effect of the low energy field magnetic influence. This animation shows the forecast of the wave height over Pacific Ocean. According to this simulation, we can expect some enormous waves passing right under the ionospheric disturbances at Western Pacific. Of course, you might say that it is just the storm surge caused by the Category 3 typhoon named Dolphin. But for me, it's just another way of telling the same story. Now, let's make it more interesting by looking at all those anomalies from global perspective. As you probably guessed already, Northwest Pacific is not the only region which is affected by the low energy field magnetic influence. It isn't too hard to point out other examples of sea surface polarization. Of course, there is much more of them, but I've pointed out just the most obvious ones. In all those cases, the low energy field influence affects the height of sea surface just as the temperature. Over those areas, lowest and highest values are being recorded very close to each other, just like on Northwest Pacific. But for now, I would like to concentrate for a while on the east coast of United States, where the magnetic polarization of seawater is stronger than in other regions. This image shows the actual temperature of the sea surface and not temperature anomalies like the maps which I was showing you before. I think that the differential should be rather obvious for most of you. This particular disturbance is important for a couple reasons. First of all, I think that it might be connected with the crash instabilities of New Madrid fault line, about which I was talking a couple minutes ago. It gives me as well a nice opportunity to explain how the low energy field magnetic tentacles affects the Earth's environment. After I published my last movie, some of you asked me to explain couple details about the magnetic reconnections, especially how the rising water temperature affects sea currents and the entire Earth's climate. According to one of my subscribers, most of anomalies can be explained by the glacial melt and cold air or water which is being pulled towards the equator, causing all the current climate extremes and seismic activities. Sorry, but I can't agree with such explanation. When I've started to build my space weather climate interactions model, I've made couple important assumptions. In one of my most important statements, I've told that our planet is being discharged from its internal energy, especially from positively charged particles. And in this case, I didn't change my mind even a bit. You need to keep in mind that temperature is just one of many energy kinds and it can be exchanged between different fields just as the electric potential. The bigger is the energy of a particle, the warmer it gets. At the lowest energy bands, particles form solid bodies. Additional energy will turn them into the form of a liquid. Then they will become gases. And finally plasma, which is the most energetic form of matter. Because according to my model, Earth is being discharged by the low energy field, magnetic tentacles are mostly interested in the particles with the highest temperature, which in the case of our planet are placed mostly in the inner layers. Weak and thin crust allows the field lines to connect with the hot liquid rock placed deep beneath the surface and suck the energy out. And this is exactly what we are seeing on this image. Warm water, which was heated up in the region where the crust is unstable, is being transferred towards the polar cap, where the energy can move further into space through open magnetospheric field lines. Some of you will probably wonder about the temperature of clouds. If in this region the inner heat is being transferred to the surrounding, why the air above it is colder than in other regions instead of getting warmer? It's because one of the main rules of electromagnetism. There has to be a difference of potential to cause the flow of current. The colder is the water vapor above the area of increased temperature, the stronger is the magnetic pull, as particles will try to nullify the differential. Of course, you don't need to believe in my explanations without any questions, but you can watch this animation of sea currents, which seems to confirm my claims in 100%. Directions in which the vectors are pointing show clearly the outflows of warm seawater towards the polar region. On the global map of sea currents, we can see that similar outflows are taking place in all areas which I've pointed out before, and which fit nicely to the anomalies on ionospheric HMF2 monitor. Of course, it's just another coincidence. And now I would like to show you a site which uses the online Google Earth application to visualize most of the oceanography data about which I was talking in last couple minutes. Of course, I will provide the link in description box under this movie. Right now it shows the speed and directions of water currents over the entire globe. Of course, there is a good reason why I'm showing you those particular readings, but to explain it we need to concentrate at a part of the planet about which I don't speak too often. The second largest continent on Earth, Africa. I'm pretty sure that when this movie will be at last published on YouTube, the quality of video will be greatly reduced, and you won't be capable to see in what directions the vectors are pointing over the equatorial belt. That's why I will draw a couple of arrows by myself. Generally, in the middle of Atlantic, water currents are moving in the same direction as equatorial air masses. That means westward. However, on the opposite side of continent, over the Indian Ocean, water currents are directed eastward, against the natural air circulation over the equator. This makes the Africa continent a kind of natural border between opposing forces which are directed outwards from the land, and divides the planet vertically. You won't see anything similar anywhere else. Well, maybe except the middle of Pacific, where the currents are directed against each other, but here the vectors are much more chaotic. And this is the time to show you the last online data visualization portal in this episode. In the difference to previous maps, this one includes the informations about the land masses and atmosphere, just as about the oceans. Right now we are watching the global map of magnetic anomalies. Colors represent the deviations of geomagnetic field from -200 to 200 nanoteslas. Although I still can't make any final conclusions, something in my guts tells me that this huge and strong anomaly in the middle of Africa has something to do with the strange behavior of ocean currents in the neighborhood. Of course, there is much more to tell about this map, as there are many similar spots on the planet's surface, but I think that this movie is already far too long, so you will have to wait for it till the next class. For the very end, a small example of low energy field flux tubes, which are capable to trigger a serious increase of seismic activity in the region of field line connection. As I said couple times before, I don't believe in coincidence. That's it for today. I promise that I will try to make shorter movies in the future, but upload them more often, to not let you suffer from the lack of another dose of information. Class dismissed. Be safe. Peace.